Hello students, how are you all? I hope that you all are good. As we know, the series of motion in a plane is going on and we have successfully finished the 7 lectures. Okay, right. So in a previous lecture that we have discussed about subtraction of given two vectors and we got that resultant of subtraction of two vectors formula. What is that? R bar is equals to under root of a square plus b square minus 2ab cos theta, and the direction of the resultant vector from a bar vector is given by tan alpha is equals to b bar sin theta by a bar minus b bar cos theta. Okay, and we have solved some examples on that concept. Right? I hope that you are enjoyed that lecture. And in today's session that we are going to discuss about resolution of vectors into rectangular components. Resolution of vectors into rectangular components. So from this concept, we have some important examples. Watch the lecture carefully and prepare the notes well. Okay, right. Shall we start the session? Okay. So my name is Rakesh Kanaganti. Welcome to our beautiful physics channel, Rakesh Sir Physics. Right. So what is the chapter going on? Motion in a plane. Motion in a plane. Okay. And what is the class number? This is the class number 08. Okay. Right. So what is the today's concept? Resolution of vectors into rectangular components. Okay, so have a look. What is the meaning of resolution of vectors into rectangular components? A simple definition is given in a textbook. So that is when a vector when a vector is splitted into is splitted into components, splitted into some components. Okay, and that components and the components are at a that components are at a right angles to each other, right angles to each other, with each other. Okay, right angles with each other. Then the components, then the components are called rectangular. Then the components are called what? Rectangular components rectangular components are orthogonal components. Orthogonal components of that vector. Of that vector. So orthogonal means what? Orthogonal is nothing but perpendicular. Orthogonal is also nothing but what? Perpendicular. Have a look. What is the meaning of vector splitted into components? The components are at right angles with each other. What all these things are? What is this? Please explain clearly. Okay. So this is a definition they are given in a textbook. But have a look. What is the meaning of this? I'm just taking the two-dimensional plane. I'm taking the two-dimensional plane. Okay. As we know, what is this? This is a x-axis. Okay, and this is y-axis, right? So this is a origin O. From this origin O, I'm just taking a vector a bar. I'm taking the vector a bar, and which is passing through the origin. Okay, right? Let's consider this point as a A. I'm just taking this point is A. Okay, so a bar vector is nothing but what? OA bar. Okay, a bar vector is nothing but what? OA bar. Okay, right. So I'm considering this a bar vector is at an angle theta. A bar vector is at an angle theta from positive x-axis. From positive x-axis, this a bar vector is at an angle theta. Okay, sir. Right. Now I'm just going to draw the two perpendicular lines from point A. From point A, I'm just going to draw the two perpendicular lines towards x-axis and towards y-axis. And just drawn the two perpendicular lines from this point A towards x-axis and y-axis. The point at which this perpendicular line touches the x-axis, I am taking that point as a B. Okay, and this point as a C. this point as a B, and this point as a C. Have a look from figure. From figure, the line OB. From figure, the line OB bar is the OB bar is the projection of, is what ma? Projection of A bar vector. What is OB? OB is nothing but projection of A bar vector on x-axis. On what? X-axis. Okay. OB shows the projection of A bar vector on x-axis. Projection of A bar vector on x-axis. I'm taking OB bar vector is equals to AX. Okay. What is this? OB bar is equals to what ma? AX. Okay. Similarly, the line, OC. The line OC. What is OC? Is the projection of, is the projection of A bar vector, projection of A bar vector on y-axis. Projection of A bar vector on y-axis. I am taking OC bar is equals to AY. OC bar is equals to, I am considering AY. So what is OC and OB are the projections of A bar vector on x-axis and y-axis. I am considering their magnitudes as AX and AY. Is it clear? Any doubts? Okay. So have a look. As we know, what is I cap? I cap is the unit vector along x-axis. What is j cap? J cap is the unit vector along y-axis. Already we are discussed in a previous lectures. Okay. From parallelogram law of vector addition. Parallelogram law of vector addition. Have a look. This is the OB bar vector. What is this? OB bar vector. This is in this direction. OB. Okay. Have a look. This is what? OC bar vector. This is a rectangle. Have a look. This is a rectangle. If it is a OC, then this is also what ma? OC. This is also what? OC. Have a look. In a rectangle, the two opposite sides are same. Then if this is OC, then this is also OC. So have a look. OC is like this and its direction is this. This is the direction. So C, OC. Right. Have a look. This is a bar vector. A bar vector. Okay. Have a look. OB and BC. OB and BC are in order. These two vectors in order, and this resultant A bar vector and this resultant A bar vector is in reverse order. Have a look. OB, OC, OB, OC are in order. So why I am taken here OC? So in a rectangle, the two opposite sides are same. That's why if this is OC, then this is also OC. The magnitudes are same. So have a look. These two are in a order, and the A bar vector is in reverse order. Therefore, it is clear that we can write A bar is equals to OB bar plus OC bar. OB bar plus OC bar. Is it clear? Right. So what is the meaning of unit vector? Unit vector is nothing but A bar vector divided by magnitude of A. Unit vector is equals to A bar vector by magnitude of A. Here we have the vectors. Now have a look. I'm just writing A bar vector is equals to A cap into magnitude of A. A cap into magnitude of A. Have a look. This is a OB bar vector. This is what? OB bar vector. And I cap is the unit vector along x-axis. So OB bar vector is equals to I cap is the unit vector. And what is the magnitude here? AX. So this can be written as AX I cap. OB bar is equals to how much ma? AX I cap. Are you getting? Plus OC bar is equals to. OC bar is equals to. What is the unit vector? J cap. What is the magnitude along this direction? AY. And it can be written as AY J cap. AY J cap. OC bar is nothing but what ma? AY J cap. This is the vector form of A bar vector along x-axis and the y-axis. Have a look. When a vector is splitted into two components, when a vector is splitted into two components and are at a right angles, have a look. AX, AY, AX, AY. So what is the angle between them? 90 degrees and are at a 90 degrees, right angles. Then the components are called the rectangular components. Now AX and AY are called what now? Rectangular components of this vector A bar. Is it clear? Any doubts? Right. So pause the video and write the notes up to here. 3, 2, 1, go. Right. So this is our diagram. So I'm just shifted this diagram from here to here. Okay. Right. So what is the vector A bar we got? The vector A bar is equals to what ma? AX I cap plus AY J cap. AX I cap plus AY J cap. Okay. Right. From this equation, we have to find the magnitude of the A bar vector. So from this equation, we have to find what ma? Magnitude of A bar. So how can we find the magnitude of A bar vector? So magnitude of A bar vector is equals to under root coefficient of I cap square. What is that? AX square plus coefficient of J cap square. What is that? AY square. So this is the magnitude of the A bar vector. So under root of AX square plus AY square. Right. Next. Important ma? Okay. Right. Now I wanted to find the direction of the A bar vector. I wanted to find direction of A bar vector. Direction of A bar vector from positive x-axis. From positive x-axis. Okay. So how can we find the direction? So direction can be given by trigonometrical function. What is that? Tan. What is that? Tan. What is the angle made by the A bar vector with positive x-axis? Theta. So this is equals to, we can write opposite side by adjacent side. Okay. So what is opposite side? This is theta. Whatever the side opposite to an angle theta is called the opposite side. So have a look. This is a rectangle. If this is AY, then this is also AY. So the opposite side is what ma? AY divided by what is adjacent side? The side which is towards an angle theta. That is AX. So the direction of A bar vector is given by, so tan theta is equals to AY by AX. Are you getting any doubts? Right, important. Okay. So when we are solving the man-brain problems, so this formula will be used. Okay. Right. Now I want to find the components of AX and AY. Components of AX and AY is equals to how much? Okay, right. To solve this, I'm just considering the magnitude of this A bar vector. The magnitude of this A bar vector. So the magnitude of A bar vector is equals to, I'm taking capital A. So magnitude of A bar vector is equals to how much now? Capital A. Are you getting? I'm just considering this magnitude as a capital A. Now this total hypotenuse becomes capital A. Okay, right. Have a look from diagram. The triangle OAB. So have a look. Triangle OAB. This is O. This is A. This is B. This is a triangle OAB. So from this triangle, what is OB? OB is nothing but AX. Okay. What is AB? AB is nothing but AY. As we know, this is an angle theta, and we are taken this A bar vector magnitude is how much? Capital A. So the magnitude of the A bar vector I am taking capital A. Okay, right. Have a look. So from this diagram we can write cos theta. What is cos theta? Adjacent side by hypotenuse. Okay. So then cos theta is equals to, what is adjacent side? From the figure, AX is the adjacent side, the side which is towards an angle theta. So what is that? AX divided by hypotenuse. What is hypotenuse? Capital A, magnitude of A bar vector. AX is equals to capital A into cos theta. Capital A cos theta. Okay, right. Any doubts? Okay. Right. Have a look. I'm just writing the equation for sin theta. What is sin theta? Opposite side by hypotenuse. Sin theta is nothing but opposite side by hypotenuse. Then sin theta. What is opposite side from this diagram? the side which is opposite to an angle theta. What is that? AY divided by hypotenuse. What is hypotenuse? Capital A. So from this we can write AY is equals to capital A sin theta. AY is equals to what now? A sin theta. What is A? Magnitude of A bar vector. A is nothing but what ma? So where A is nothing but magnitude of A bar vector. Okay. Are you getting? Okay. A cos theta is the component of AX. A sin theta is the component of AY. So we got AY is equals to what ma? A sin theta. What is AX? We got AX component is equals to A cos theta. Okay. So what is AY component? A sin theta. What is AX component? A cos theta. Is it clear? Any doubt? So these two are the components of AX and AY. So AX is equals to A cos theta. AY is equals to A sin theta. Substitute AX and AY components in equation 1. Okay, we have to substitute AX AY components in equation 1. Then we will get A bar is equals to what is AX? AX is equals to A cos theta into I cap plus what is AY? AY is nothing but A sin theta into J cap. So this is called a resolution of the vectors. Okay. So this is called what ma? The resolution of vectors in rectangular component. Any doubt? And what we got? Vector A bar is equals to what ma? A cos theta I cap, A sin theta J cap. So this is along y axis and this is along x axis, and this is called what? Resolution of vectors. Okay. So you must remember what is the vector A bar? Vector A bar is equals to AX I cap, AY J cap. Okay, what is the magnitude of A bar vector? Whenever you are finding the magnitude, just you have to take root and the square of I cap component plus the square of J cap component you have to take. How to find the direction? Direction can be given by tan theta from the positive x-axis. So tan theta is equals to opposite side by adjacent side, that is AY by AX. Are you getting ma? Right. So what are the components of AX and AY? So the components of AX and AY are A cos theta and A sin theta. So after substituting these two in equation 1, we get A bar is equals to A cos theta I cap plus A sin theta J cap. Is it clear? Any doubts? Right. So pause the video and write the notes clearly. Okay? Right. 3, 2, 1, go. Right. Have a look. We are taken a vector in a xy plane. Okay. So this is x-axis, y-axis, origin. So this is A bar vector. Okay. So we are considered the magnitude of A bar vector is capital A. So this is an angle theta. The component of this A bar vector or the projection of this A bar vector along x-axis we are taken AX. Okay. And the component of A bar vector or projection of A bar vector on y-axis is AY. Okay. So AX and AY are the magnitudes of this A bar vector along x-axis and the y-axis. Okay. Right. Have a look. So what we got? The vector A bar is equals to AX I cap plus AY J cap. So what is I cap? What is J cap? I cap is the unit vector along x-axis and J cap is the unit vector along y-axis. Okay. Right. What is the magnitude of A bar vector? So the magnitude of A bar vector is equals to under root of AX square plus AY square. Are you getting ma? Okay. So what is the direction of the A bar vector from positive x-axis? Tan theta is equals to AY by AX. Okay. So what is this? This is a rectangle. Okay. So opposite sides in a rectangle are same. If this is AY, then this is also AY. If this is AX, then this is also AX. Okay. Right. So this is a direction. This is the magnitude of A bar vector, and this is what? A bar vector. To find the values of AX and AY, we have taken one right angle triangle OAB. So from this right angle triangle, we got AX is equals to what ma? A cos theta. Okay. And the AY is equals to what? A sin theta. Okay. So after substituting AX, AY values in this equation, we got A bar is equals to AX is equals to A cos theta into I cap. So AX is equals to A cos theta into I cap plus AY is equals to A sin theta into J cap. Okay. So all these things that we have discussed in a few minutes ago. Have a look. So when we are finding the x component and y component of this a bar vector, no need to take a right angle triangle. Okay. So from that right angle triangle, the opposite sides of a rectangle is same. So cos theta is equals to adjacent side by hypotenuse. Okay. So sin theta is equals to opposite side by hypotenuse. After that, we get these values. Okay. So no need to do all these things. In a simple way, we can easily find the components ax and the ay. So we have a shortcut. Have a look. So in this example, I'm taking the same example. Okay. So in a xy plane, there is a vector called a bar. Okay. And whose magnitude is capital A. Magnitude of a bar vector is capital A. Now this a bar vector is making an angle theta with the x-axis. Now you want to find the components ax and the ay. Ax and the ay. Then just to follow the simple trick. Have a look. If you want to find the ax, okay, so just rotate this vector towards an angle theta. Rotate this vector towards an angle theta along theta side. Just write this magnitude into cos theta. Along theta side, magnitude into cos theta. Now we are here. Okay, now we are here. So what is this? A cos theta. And perpendicular to this, just write this magnitude into sin theta. Have a look. Ax is equals to, we got a cos theta, and ay is equals to a sin theta. That's it. No need to do anything. Are you getting? And if you want to find the a bar vector, a bar is equals to ax I cap plus ay j cap. Are you getting? So this is positive x-axis I cap, this is positive y-axis, and j cap. So a bar is equals to, what is ax ma? A cos theta I cap plus what is ay, we got a sin theta j cap. Have a look. हो गया, खत्म. Any problem ma? Right. So I'm just taking a second example. Okay. So this is a x-axis and this is y-axis. Okay. And this is a bar vector and its magnitude is capital A. Okay. At this time, the a bar vector is making an angle theta with y-axis. Now ay is equals to how much? Ax is equals to how much? So this is a I cap and this is j cap. So pause the video and try the solution. So find the ax and the ay. 3, 2, 1, go. What we have to do? Just rotate this a bar vector towards an angle theta. Just rotate this a bar vector towards an angle theta along theta side. So the magnitude of the vector into cos theta. Now we are here. Perpendicular to this. Ax is equals to what ma? A sin theta. Ax is equals to how much? A sin theta. हो गया. So now a bar vector is equals to what ma? Ax I cap plus ay j cap. Okay. So a bar vector is equals to, what is ax? Ax is equals to a sin theta I cap plus ay is equals to a cos theta j cap. That's it. Over. So just one thing you should remember. So whenever you are making the resolution of vectors, just rotate the vector towards an angle theta along theta side, magnitude of the vector into cos theta, and perpendicular to this, magnitude of the vector into sin theta along theta side, cos theta, perpendicular to this, sin theta. That's it. Any problem? Right. So let us solve one more example, and this is a big example. Okay. La 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 la. Okay, right. So this is what x-axis, this is what y-axis, and this is what ma? Negative x-axis, and this is what? Negative y-axis. Is it clear? Any doubt? Negative x-axis is yes. Okay, as we know that along the positive x-axis, I cap is the unit vector. Along negative x-axis, minus I cap is the unit vector. Along positive y-axis, j cap is the unit vector. Along negative y-axis, minus j cap is the unit vector. Okay, any problem? Right. So this is a bar vector and its magnitude is capital A. Okay. So this is a b bar vector and its magnitude is capital B. And I'm taking a c bar vector. Okay. And its magnitude is C. Right. So I'm taking a d bar vector and its magnitude is capital D. Okay. So this a bar vector is making an angle alpha with the positive x-axis. A bar vector making an angle alpha with the positive x-axis. So now at this time, this b bar vector is making an angle beta with the positive y-axis. So B bar vector is making an angle beta with the positive y-axis. So this C bar vector is making an angle gamma with the negative x-axis. This C bar vector is making an angle gamma with the negative x-axis. Right now, this D bar vector is making an angle delta with the negative y-axis. Now, this D bar vector is making an angle delta with the negative y-axis. The question is find out A bar, comma B bar, comma C bar, and D bar vectors. A, B, C, D vectors is equal to how much? This is a given question. Right? Let's we solve the solution. Okay, sir. Right. Solution. I want to find out A bar vector. What is A bar vector? A bar is equals to AX I cap plus AY J cap. I want to find AX and AY. So as we know that this is what AX and this is AY. Is it clear? Any doubt? To find these components AX and AY. So what we have to do? So this is a bar vector and its magnitude is A. So what we have to do? We have to check an angle theta. So now this A bar vector is making an angle alpha with the positive x-axis. An angle alpha with the positive x-axis. Right? Ho gaya. So this is A bar vector. Along theta side. Along theta side. We get AX is equals to what? So magnitude of this vector. Along theta side. Along theta side. A cos theta. In the place of theta, we have alpha. That's it. And perpendicular to this, ay is equals to a sine theta. But at the place of theta, we have alpha. Khatam. Khatam. Any difficulty is there? No difficulty is there, right? Easy one, na? So a bar is equals to what is ax? A cos alpha I cap plus what is ay? A sine alpha j cap. That's it. This is A bar vector. Now we have to find B bar vector. So B bar vector is equals to what, ma? Bx I cap plus by j cap. We have to find bx and the by. So along x-axis, this is a B bar vector. Along x-axis, the component is bx. Along y-axis, the component is by. Okay, are you getting? What we have to do? We have to check where the vector is making an angle. Have a look. This is a B bar vector, and this B bar vector is making an angle beta with the y-axis. Beta with the y-axis. Now what we have to do? So just rotate this B bar vector towards an angle beta. So rotate this B bar vector towards an angle beta. Have a look. Along theta side, magnitude of vector into cos theta. Magnitude of vector into cos theta. That's it. Now here we have. So B cos theta and perpendicular to this bx is equals to b sin theta. Bx is equals to b sin theta. We got bx value and by value. What we did? Just rotate the vector towards an angle theta. Along theta side, you will get magnitude of this vector into cos theta, and perpendicular to this will get this magnitude of the vector into sin theta. That's it now. Okay, let's have a look. So B bar is equals to what is bx? B sin theta. Bx is equals to b sin theta. Have a look. Here we have I cap, but this bx is along negative I cap. Is along negative I cap. So at the place of I cap, you will get minus I cap because the bx, the component bx is along negative x-axis. Along negative x-axis, what is the unit vector? Minus I cap. Is it clear? Any doubts? Okay. Plus, what is by? By is equals to b cos theta and j cap. Have a look. This is a positive y direction and the unit vector is j cap. Any difficulty is there? Right. Let us find out. This is the first one. This is the second one. And the third one. C bar vector. What is C bar? C bar is equals to Cx I cap plus Cy j cap. Okay. Right. Have a look. Where is C bar vector? Right. Now this C bar vector is making an angle gamma with the negative x-axis. Now what we have to do? We have to find the components of Cx and along y-axis Cy. Cx is equals to how much and Cy is equals to how much we have to find. Right. So what we have to find? We have to find Cx and Cy. For that, what we have to do? Just rotate this C bar vector towards an angle theta. Just rotate this C bar vector towards an angle theta. So at the place of theta, we have what, ma? Gamma. So along theta side, you will get C magnitude of the vector into cos theta. At the place of theta, we have gamma. So Cx is equals to, we got what, ma? C cos gamma, and perpendicular to this, and perpendicular to this, and perpendicular to this, cy is equals to, you will get c sin gamma, c sin gamma. So along theta side, c cos gamma, and perpendicular to this, c sin gamma. That's it. Just substitute. And c bar vector is equals to cx. What is cx? C cos gamma. And this c cos gamma is along negative x-axis. What is the unit vector along negative x-axis? Minus I cap. Okay, have a look. Plus cy. What is cy? C sin gamma. C sin gamma. What is the unit vector along negative y-axis? Minus j cap. Minus j cap. Okay, so minus into plus, minus. So overall you will get c sin gamma into j cap. So this is a c bar vector. Are you getting? Now we find the d bar vector. So fourth one. So d bar vector is equals to dx I cap plus dy j cap in general. Okay. So have a look. Here we have d bar vector, and this d bar vector is making an angle delta with the negative y axis. Now to find dx along x axis, you will get dx, along y axis you will get dy. Okay, now what we have to do, just rotate this d bar vector towards an angle theta. Rotate this d bar vector towards an angle theta. Along theta side you will get d cos theta. At the place of theta we have delta. Okay, now perpendicular to this, now perpendicular to this, so perpendicular to this is x-axis, and the dx is equals to d sin delta. Along theta side d cos delta, and perpendicular to this d sin delta. Is it clear? Any doubt? Right. So d bar vector is equals to, what is the value of dx? Dx is equals to d sin delta I cap, because it is a positive x-axis. Along positive x-axis, what is the unit vector? I cap. And dy, what is dy? Dy is equals to d cos delta. Have a look. This is along negative y direction. This is along negative y direction. Along negative y direction, what is the unit vector? Minus j cap. So minus into plus, minus. Okay. So finally you got d bar vector is equals to d sin delta I cap minus d cos delta j cap. Is it clear? Any doubt? Right. Simple one. So simply we can find the resolution of a given vector in a plane. So what we have to do? Just whatever the vector they are given, just rotate it along theta side. Along theta side, magnitude of the vector into cos theta, and perpendicular to this, magnitude of vector into sin theta. That's okay. So pause the video and write the concept. Pause the video and write the concept. 3, 2, 1, go. Right. So and just to bring the two example problems. Okay. So have a look. What is the first example problem they are given? A bar is 2 centimeters long and 60 degrees above the x-axis. Okay, they are given the magnitude of the A bar vector. How much? 2 centimeters long and 60 degrees above the x-axis. 60 degrees above the x-axis in the first quadrant. The vector B bar is 2 centimeters long. The vector B bar is 2 centimeters long and 60 degrees below the x-axis in the fourth quadrant. Okay, so pause the video and try the solution. What we have to find? We have to find a bar plus B bar. Okay, so pause the video and try the solution. 3, 2, 1, go. Have a look. I'm going to do the solution. So what they are given? They are given two vectors, A bar and B bar. So x-axis, y-axis, minus x, minus y. Okay. So A bar is 2 centimeters long and 60 degrees above the x-axis in the first quadrant. As we know, this is the first, second, third, and fourth quadrants. Okay. Now this A bar vector is in first quadrant. Is in first quadrant. Have a look. This is the first quadrant. A bar vector, and its magnitude is equals to how much, ma? 2 centimeters, and it is making the angle 60 degrees. The angle 60 degrees with the positive x-axis. 60 degrees with the positive x-axis. Have a look. Vector B bar is 2 centimeters long and 60 degrees below the x-axis in the fourth quadrant. So there is a one more vector. Let us say this is a B bar vector, and whose magnitude is also 2 centimeters, and it is making an angle 60 degrees below the x-axis. An angle 60 degrees below the x-axis in a fourth quadrant. In a fourth quadrant. They are asking A bar plus B bar is equals to how much? Okay, so we have to find the A bar vector. What is the A bar vector? Ax I cap plus Ay j cap. This is the A bar vector. Okay, so have a look. This is Ax and this is Ay. What is the magnitude of the A bar vector? 2 centimeters. What I told you that whenever you are finding the Ax and Ay, so just rotate this A bar vector towards an angle theta. Rotate A bar vector towards an angle theta. So towards an angle theta, we have the component Ax. Ax is equals to A cos theta. Ax is equals to A cos theta. So what is the magnitude of A? 2. Then you will get 2 cos theta. Ax is equals to how much? 2 cos theta. What is the angle here? 2 cos 60. 2 cos 60. Theta is equals to how much? 2 cos 60. This is the value of Ax. And next what we have to do? So rotate this vector perpendicular to this. Perpendicular to this. Perpendicular to this. You will get A sin theta. So what is the magnitude of A? 2. What is the angle theta? 60 degrees. So Ay is equals to 2 sin 60. Any difficulty is there? No difficulty is there. Okay. So A bar is equals to Ax. What is Ax? 2 cos 60 I cap, because it is along positive x-axis. I cap is the unit vector, plus Ay. What is Ay? 2 sin 60 j cap, because it is along positive y direction. Okay. So 2. What is the value of cos 60 by 2? I cap, plus 2 into what is the value of sin 60? Root 3 by 2 j cap. So 2 get cancelled out, 2 get cancelled out, and I bar vector is equals to, we got I cap plus root 3 j cap. Okay, right. Next we have to find what? B bar vector. B bar is equals to bx I cap plus by j cap. Okay, right. So now we have to find bx and the by values. Right. So along x-axis you will get bx, and along y-axis we will get by. Okay. So have a look. This is a 2 centimeters, and it is making an angle 60 degrees with positive x-axis along theta side. Along theta side, this magnitude of the vector into cos theta, and perpendicular to this and perpendicular to this magnitude of the vector into sin theta. Theta is equals to sin 60. So we got bx value. What is the value of bx? 2 cos 60. 2 cos 60, and it is along positive x-axis I cap, its direction, plus by. Have a look. By is in negative y direction, and its unit vector is minus j cap. Okay. So by is equals to how much more? 2 sin 60, and its unit vector j cap is nothing but minus j cap. So minus into plus minus. Are you getting any doubts? Okay. So that is equals to 2. What is the value of cos 60? 1 by 2 I cap minus 2. What is the value of sin 60? Root 3 by 2 into j cap. 2 get cancelled out, 2 get cancelled out, and we got I cap minus root 3 j cap. So what is this? This is a B bar vector, and we got A bar vector and a B bar vector. What they are asking? A bar plus B bar is equals to how much? Okay. So what is the value of A bar? I cap plus root 3 j cap, plus what is B bar vector? I cap minus root 3 j cap. So plus root 3 j cap minus root 3 j cap cancel out. I cap plus I cap 2 I cap. So A bar plus B bar is equals to how much more? 2 I cap. Any difficulty is there? No difficulty is there now? Easy problems are? Okay, very good. So let us we discuss about this problem. Okay. B cos 60. Right. Solution. So what is the problem they are given? Have a look. A vector has x component of minus 25 units and y component of 40 units. Okay, they are given x component of a vector. How much? Minus 25 units, and y component is given how much? 40 units. Okay, find the magnitude and the direction of the vectors. We have to find the magnitude and direction of the vector. So have a look. This is a x component, and its value is minus 25. X component minus 25. Have a look. Okay, this is positive x-axis, minus x-axis, y-axis, minus y-axis, plus I cap, minus I cap, plus j cap, minus j cap. Okay, minus 25 they are given. Minus 25 in this direction. Okay, along negative x direction. Plus 40. along y component. Y component plus 40. Y component plus 40. So have a look. This is a minus x component and this is y component, minus x plus y. So now whatever the vector they are given, that vector lies in between minus x and a positive y axis. Okay, minus x and a positive y axis. So have a look. The vector is like this. Okay, let us say this is a vector a bar. We don't know, but I'm just considering this vector as a bar vector. Okay, so its x component is equals to how much, ma? Ax is equals to minus 25 units. Y component ay is equals to how much, ma? 40 units. 40 units. So I wanted to write a bar vector. What is a bar vector? Ax I cap plus ay j cap. Ax I cap plus ay j cap. So what is the value of ax we got? Ax is equals to minus 25 I cap. So minus 25 I cap. I cap direction is what, ma? Minus. That means along negative x direction plus ay. What is ay? 40 along positive y direction j cap. So this is our required a bar vector. This is our required a bar vector. Is it clear? Now what we have to find? We have to find its magnitude and the direction. To find magnitude of this a bar vector. So magnitude. Okay. So how to find the magnitude? We have the formula. So the magnitude of a bar vector is equals to under root of ax square plus ay square. Okay, so that is equals to under root of ax square. Ax value is how much, ma? 25 whole square. Although if it is minus 25, if you place minus 25 in a square, it becomes plus. So plus b square under root 40 whole square under root of 25 whole square. 25 is a 625 plus 40 square. 4 4 is 16 double 0 1600. So this is equals to under root of triple two 5. If you add these two, you will get how much? Triple two 5. 5 2 6 plus 6 12 1 plus 1 2 triple two 5 under root of triple two 5. So this value is nearly equals to 47.16. 47.16, and this is the magnitude of the a bar vector. What is the magnitude of the a bar vector? 47.16. Is it clear? Any doubt? Okay. So next what we have to find? We have to find the direction. So to find the direction, we have the formula. What is that? Tan theta is equals to ay by ax. Tan theta is equals to ay by ax, where theta is the angle made by negative x-axis. Where theta is the angle made by negative x-axis with a bar vector. Have a look. If you draw the perpendicular lines like this, okay. So the side which is opposite to an angle theta is nothing but what? Ay component. The value of ay is equals to 40 divided by what is the value of ax? Minus 25. Okay, so 25 ones are 25, 25 ones are 25, 15 remains, pointer 0 150. So 25 6 is 25 6 150, 25 6 150. Are you getting? Is equals to here minus is there, so minus 1.6. So tan theta is equals to, we got how much? Minus 1.6. Then theta is equals to tan inverse of 1.6 minus 1.6, and theta is equals to, and theta is nearly equals to, so tan inverse of 1.6 minus 1.6, its value is nearly equals to 58 degrees. Is nearly equals to how much, ma? 58 degrees. So theta is equals to how much? 58 degrees. So now this a bar vector, is making an angle, 58 degrees with the negative x-axis. 58 degrees with the negative x-axis. Or if you wanted to say in terms of positive x-axis, have a look. This total angle is 180 degrees. From here to here, 58. So what is the remaining angle? 122. 122 degrees. Now if you wanted to say in a positive x-axis, now this a bar vector is making an angle 122 degrees with the positive x-axis. Okay, with respect to negative x-axis, it was making how much, ma? 58 degrees. With respect to positive x-axis, it is making 122 degrees. Okay, so with the negative x-axis, so theta is equals to 122 degrees with the positive x-axis. This is in anti-clockwise direction. Anti-clockwise direction, have a look. Anti-clockwise direction, this is clockwise direction, this is what, ma? Clockwise direction. So likewise you have to solve the problems. Okay, any problem, any difficulties there? Right. So pause the video and write the solutions. Pause the video and write the solutions. 3, 2, 1, go. Right. Again, I'm bringing the two examples. Example number 3 and example number 4. Have a look. What is the example number 3? They are given a vector root 3 I cap plus j cap. They are given one vector rotates about its tail through an angle 30 degrees, and that vector is rotated about its tail through an angle 30 degrees in the clockwise direction. They are rotated that vector in clockwise direction. What they are asking? Then the new vector is, they are asking to find what is the new vector. Okay, right. Have a look. Solution. So they are given one vector. So let us consider that vector is a bar. So a bar is equals to how much, ma? Root 3 I cap plus j cap. Okay, right. So in general, what is the formula for a bar vector? A bar is equals to ax I cap plus ay j cap. Okay, so have a look. Just taking the xy plane. So this is the x-axis and this is the y-axis. Okay, right. So compare these two equations. Compare these two equations. What is the value of ax? Ax is equals to root 3 and the ay is equals to how much? Ay is equals to, so here ay, at the place of ay we have 1 into j cap, then ay is equals to how much more? 1. Okay, I'm just comparing these two equations. Have a look. Here root 3 I cap is there. So what is I cap? I cap is the unit vector along positive x direction. So here plus j cap is there. What is plus j cap? So j cap is the unit vector along positive y direction. And they are given one vector, and this vector is in between plus I cap and plus j cap. Plus I cap and plus j cap. Have a look. Plus I cap plus j cap. That means whatever the vector they are given, that lies in between positive x-axis and the positive y-axis. That means in a first quadrant. So this a bar vector is in first quadrant. So this is a bar vector. Okay, this is a bar vector. Okay, so what is the value of ax? The value of ax is equals to 3. What is the value of ay? Ay is equals to how much, ma? 1. If this is 1, this is also 1. Ay is equals to 1 because it is a rectangle, the opposite sides are same. Now I want to find the angle made by this vector. I want to find the angle made by this vector with positive x-axis. Angle made by the a bar vector with positive x-axis in anti-clockwise direction. So from the slope concept we are doing the same thing. Okay, this is a slope. We are taking an angle theta in anti-clockwise direction towards the slope. Okay, so this is an angle theta. So to find an angle theta we have the formula. What is that? So tan theta is equals to ay by ax. Ay by ax. What is ay? The value of ay is 1. What is the value of ax? The value of ax is root 3. Then tan theta is equals to, we got 1 by root 3. Okay, so tan theta is equals to 1 by root 3. 1 by root 3. So 1 by root 3 can be written as tan 30. What is the value of tan 30? 1 by root 3. Okay, sin 30 1 by 2, cos 30 root 3 by 2. 1 by 2 divided by root 3 by 2. 2 get cancelled out and you will get 1 by root 3. Okay, so tan get cancelled out and theta is equals to 30 degrees. Theta is equals to how much more? 30 degrees. That means this a bar vector is at a 30 degrees from positive x-axis, in anti-clockwise direction, ACW direction. Are you getting any doubts? Right. So what is the a bar vector? We have root 3 I cap plus j cap. If I wanted to find its magnitude, so magnitude of a bar vector is equals to how much, ma? Under root of root 3 whole square plus 1 square. So magnitude of a is equals to under root of root 3 whole square. Root 3 whole square means 3 plus 1 square is 1. So finally we get root over 4. What is the value of root 4? Root 4 value is how much, ma? 2. So the magnitude of this a bar vector is equals to how much? 2. How much, ma? 2. Okay, so this is about given a bar vector. Its magnitude is 2. Okay, and its direction is 30 degrees in anti-clockwise direction from positive x-axis. So this is a bar vector and it is at a 30 degrees in anti-clockwise direction from positive x-axis. Okay, so now what they are did, they are rotated this a bar vector, they are rotated this a bar vector in clockwise direction, they are rotated this a bar vector in clockwise direction with an angle 30 degrees, with an angle 30 degrees. Have a look, this a bar vector again rotated 30 degrees in a clockwise direction. So it is at a 30 degrees from positive x-axis initially. Now they are rotated in a clockwise direction with 30 degrees angle after some time. Now what happened? This is a anti-clockwise direction 30 degrees. This is clockwise direction 30 degrees. 30 minus 30, 0. Now this a bar vector is lies on a positive x-axis. Is lies on a positive x-axis. So this is the new position of the a bar vector. Are you getting? So initially it is at a 30 degrees in anti-clockwise direction. They are rotated with 30 degrees in clockwise direction. So anti-clockwise 30, clockwise 30. Overall, an angle is 0. Now this a bar vector is on a positive x-axis. Is on positive x-axis. So what is the magnitude of this a bar vector? 2. 2 is the magnitude of this a bar vector. So what is the unit vector along the positive x-axis? I cap. Okay. Now what is the new vector? What is the new a bar vector? A bar is equals to ax. We can write ax I cap plus ay j cap. So ax is what? Magnitude of the a bar vector along x-axis. Along x-axis, its magnitude is how much? 2 I cap. Now ay we have to find. Have a look. This a bar vector is completely lies on positive x-axis. Completely lies on positive x-axis. Any y component is there? No y component. So that is how much? 0 j cap. So 0 into j cap, 0 j cap. So the new position of the a bar vector is equals to how much? 2 I cap. How much ma? 2 I cap. Are you getting any doubts? Right. So pause the video and write the solution. So likewise, so whatever the rotation problems are there, you have to find like this. First what we have to find? We have to find at what angle the a bar vector is lying from positive x-axis. Then after we have to check in which direction they are rotated the a bar vector. Okay. So after that, do like this and you will get the answer. Any difficulty is there? No difficulty is there. Practice, practice, practice. Do more practice, then you will get the perfection in doing the problems. Okay, right. Shall we go to that problem? Okay. The example number 4, what they are given. So a rain is falling vertically with a speed of 35 meter per second. So I'm just drawing the diagram based on given question. Okay. So the rain is falling down in a vertically downward direction. Velocity of rain. VR means what ma? Velocity of rain. How much? With a speed of 35 meter per second. Okay. Wind starts blowing after some time with a speed of 12 meters per second in east to west direction. Now what happened after some time? The wind starts blowing from east to west direction. So as we know, this is a east direction and this is a west direction. Now the wind is starts blowing from east to west direction. VW is nothing but what? Velocity of wind. What is the speed? 12 meter per second. This is the velocity of the wind. Okay. So now what they are asking, in which direction should a boy waiting at a bus stop hold his umbrella? So at this condition, the boy is standing at a bus stop. Okay, na? He is standing at a bus stop. So in which direction this boy should hold his umbrella? In which direction the boy should hold his umbrella to prevent from the rain? To prevent from the rain. So now I am considering the resultant of these two velocities like this. So this is a resultant of these two velocities r bar. Now I am considering this resultant vector is making an angle theta with the vertical. Is making an angle theta with the vertical. So to find the direction of r bar, we have the formula. What is that? Tan theta is equals to what ma? Tan theta is equals to opposite side by adjacent side, opposite side by adjacent side. Have a look. So this is a resultant vector r bar. Okay, resultant vector r bar. So according to parallelogram law, so if you draw the two perpendicular lines, so opposite side, the side which is and opposite to an angle theta, the side which is opposite to an angle theta. Have a look, this is 12 meter per second and it is a rectangle. In rectangle, two opposite sides are same. If this is 12, then VW is equals to, this is also 12 meter per second. So have a look, this value is, VR is equals to how much now? 35 meter per second. If this is 35 meter per second, then VR is equals to 35 meters per second. So tan theta is equals to, tan theta is equals to opposite side. What is that? 12 divided by adjacent side. What is adjacent side? Divided by 35. So if you solve this, we will get 12 divided by 35, 0.120. 35 3s are 35 4s are 343, 0.3. So tan theta is equals to, we got how much ma? So tan theta is equals to 0.343. So its value, theta is equals to tan inverse of 0.343. So and you will get nearly equals to 19 degrees. So theta is equals to how much ma? 0.343 is equals to 19 degrees. If you use the calculator, you will get this answer. Okay, right. So from this result, it is clear that so the boy has to shift his umbrella 19 degrees towards east, because the wind is flowing from east to west. He has to rotate his umbrella towards east direction with 19 degrees. Then he is prevented from the rain. Are you getting any doubts? Right. So pause the video and write the solutions. So pause the video and write the solutions. 3, 2, 1, go. Right. So this is the end of the today's lecture. We will meet on a next lecture. So I hope that you are enjoyed today's lecture. Okay. Right. So keep watching and write the notes properly. Okay. Right. So this is Rakesh Kaniganti signing off. Stay tuned. Jai Hind.